Howdy folks, Root Beer here, and we're looking at question 15 on the 2006 Fermat paper. The points 5, 3 and 1, -1 are plotted on a sheet of graph paper. Hey, for those of you who bring graph paper to the, or who are given graph paper as rough paper, this will certainly be right up your alley. The sheet of graph paper is folded along a line so that the point 5, 3 lands on top of the point 1, -1. Okay, so we start thinking how do points transform when they're folded along lines? Well, folding along a line is sort of like reflecting in that line in terms of graphing. So if we understand reflection better than folding, maybe we don't actually have paper, although I would recommend you at least use some rough paper and draw a crude graph and see how folding works. That's always a great thing to do. But, it works the same as reflecting, so that's something we can keep in mind. Either understand it by folding or understand it by reflecting. Anyway, so we want to know what's the equation of the line that represents the fold here. Okay. So we'll just very briefly plot these points. And it's 1, -1, which is down here, I'll say. 1, -1, and it's 5, 3. So we go over by 5 and up by 3. So we've got some point or some line here. And it sort of runs along here, and then this one is folded over. So this is 5, 3, and this is 1, -1. So we fold. But as I say, folding is the same as reflecting. And so what actually happens is, if you like to think of it like a mirror, we can connect these 2 points by lines. The shortest distance between from each of these points to the line meets at a right angle, and they will happen to meet at the same point. Okay, same point on this line. And it'll also happen to be the midpoint of the line between the two of them. So, so here's what we can do, knowing this information. If we can figure out the equation of the line between 5, 3 and 1, -1, our folding line has to be perpendicular to that. How do we get the perpendicular? Well, negative reciprocal. So we can get the slope of the folding line. And we can also get this point here. It's the midpoint between 5, 3 and 1, -1. How do we calculate midpoints? Well, we add up the x-coordinates and average them. And then we average the y-coordinates as well. So we're going to get 6 over 2, 3, and 2 over 2, 1. So our midpoint here is 3, 1. This has to be on the folded line. Now, slope from the line between our 2 points is it's rise over run. So that's going to be the difference in the y-coordinates over the difference in the x-coordinates. So our slope is going to be 3 minus -1, 4 over 5 minus 1, which is 4, so 1. Therefore, the fold has slope negative reciprocal. This is how, this is just a very nice, well-known fact from grade 9 or grade 10, depending on where you live, that perpendicular lines have slopes that are negative reciprocals. So the fold has a slope of -1, and it passes through 3, 1. So y equals -1x plus b. Well, we know 1 is -1, 3 plus b, so that's -3 plus b. b is going to be equal to 4. So our equation is going to be y equals -x plus 4. So now we've got all that done. We try and find the line, and they have everything in y equals mx plus b form. We could either note that and then make sure our answer matches that, or if I'd got y equals mx plus b form and then wanted standard form, something to know is how to convert between the two of them. But we see -x plus 4 is right here. So this plus 4 and the -1, so we get D. But just what I'm thinking here is, had I stopped to look, I could see that all the slopes are going to be -1. So really, if I just bothered to calculate the midpoint and seeing which of those is on which of these lines, or even just set up the y equals negative x plus b and plug that point in. Probably could have done this slightly faster. But no use worrying about that now. We're done with question 13. We're going to move on to question number 16. Hopefully you guys will join me for that one. I'll see you there.